Okay, this is lecture 3, algorithms, languages, and variables. So we did see variables in the last lecture. We saw x, y, and z were defined to hold what was in the what were in the labels or the slots in the slot machine. And we also saw one more variable. What was that? We saw the counter variable. Okay, last lecture we practiced making simple programs. Program A, display the time and date on demand, and the goal was to display the time and date. Program B was a slot machine, and the goal was using a timer to achieve simple game automation. Today we will start our discussion of Visual Basic programming, understanding algorithms and what they have to do with computer languages like Visual Basic, declaring and using variables, which actually we already did, mathematical operators and statements, and we'll also get some more Visual Basic practice by making two simple programs, a simple calendar and a price calculator. In fact, let's quickly take a look at the two programs we're going to make. So here, that was all about variables and so on. But here's a simple calculator. So you can see that it has a plus, a minus, a times, a divide, and some other operations. And we want to make it. And we want to make it so that the user can put in two values like 6 and 5, and maybe divide 6 by 5 and get 1.2. So that's one of the programs we want to make. The other program we want to make is to improve this calculator a little bit, okay? Or actually make a price calculator, okay? So something like this. You put in a product name, you put in a price, you put in a quantity, and it gives you this information. That's the result. Okay, so we want to make these two, but before that, we want to discuss some topics. The first slide here is information versus data. So we might make a distinction between information and data. So if you think about those two words, information and data, you might think, well, data is certainly related to information, right? Like when you have data, you might say, oh, I have some information. So they're kind of related. So he says that he wants to make a distinction between them. He wants to make this distinction clear. So, okay, let's see what he says. Information is a description of facts in any form. So it could be handwritten notes in a notebook, he says. It could be handwritten tallies of baseball statistics. On the other hand, we'll call data is information which has been converted into an ordered, formatted digital form. Well, you may not agree exactly with that definition of what data is, or even what that definition is of what information is, but let's just use these definitions for the time being. Okay, so we're going to say information is the description of facts in any form, but this is somehow converted into an ordered, formatted digital form, which permits direct processing by a computer. So information is like handwritten notes, but you can't really use that in a computer until it's turned into something digital. So examples are an MS Word file, because that is digital, because it's written on the computer, containing a set of entered notes, or an Excel worksheet. Okay, so that's the kind of distinction he wants to make. The transformation of information into data can involve collation. That means sorting of written information into a standard order, so we collate things. Formatting, for example, digitalization, analog to digital conversion. So these are kind of abstract concepts here. It's not necessarily clear why we have to make these distinctions, but anyway, pre-processing, which is a conversion of raw data into statistical data for further processing. Okay, let's go on to the next